And start a recording, so we should be going. And one last audio check. Cool. All right, how's everybody doing today?
Pretty good.
Doing good. Not bad.
So hopefully nobody's having too much issue with the fires in the area. I know it was pretty sketchy, especially over the weekend. But looks like things are getting a little better contained. So hope everybody's been okay with that. And if not, hope you're doing what you can to stay safe. So bunch of things to talk through today. I want to take a quick look at the last ODP from last week. That was the remove one function, I believe. And then want to take a look at back quotes. So we were talking about variables and such in Bash. And I mentioned there were three kinds of quotes: double, single, and back quotes. And we talked a little about the first two, but not the third. So I want to go through that. And then I want to spend a chunk of today's time, possibly the rest of today, looking at PA2, and in particular, thinking about how we can write some code to test the different functions that we're writing to build up into PA2. And so I want to pseudocode or maybe real code some test programs. I could never remember if backquote was accent grave or accent aigu. They always flipped around in my brain. All right, so before we get into all of that, any questions? Anything anybody wants to talk about up front?
There's no way we could go over the pseudocode for the display results function. I don't know why,
Sure
but
thing.
it's awesome. Thank you.
Yeah, that's totally legit. Oh, it is a graph. Cool. Okay. All right, let's see. So display results. And let me pull up my copy of the assignment just so I don't do this from memory, but I think it just takes the keywords, the tally, and the num words. So keywords, tally, and num words. So that's the array of keywords. So an array of strings. That's an array of integers, which says how many times each keyword appeared, and then that's the number of keywords in the file. So this is a for loop basically. So we can go from 0 to num words -1. And KW is the array of keywords, so we can print keyword bracket I and tally bracket I. So remember, these are parallel arrays. So this is an array of keywords. This is an array of counts, how many times each keyword appeared. So if KW looks like this, so let's say it contains hello, cool, and bye, and num words is 3. Then count is this parallel array. And so if the word hello appeared 5 times, count 0 would be 5. If keyword bracket 1 is equal to cool and cool appeared twice, then count bracket 1 would be equal to 2. And if bye appeared 6 times, then count bracket 2 would be 6. And so the tally function, right, takes these things and a word. And if you call tally with, the word cool, it'll search through here, see that index 1 has the word cool, it would increment count bracket 1. This would become a 3. So display results is a single for loop with one print statement, which prints out keyword bracket I and tally bracket I. So for I is 0, we'll print out hello colon 5. And then I is 1, it'll print out cool colon 2, and so on. And this thing is a string. So that gets printed with a %s, and this is an int, so that gets printed with a %d. And the
Got it.
argument types.
And
Yeah,
we
go
don't
ahead.
need to declare them in the function itself, right?
So in the declaration of the function, you're going to name the 3 arguments and say what types of things they are. So this will make keywords an array of strings. This will make tally an array of integers, and this makes numwords an int. And so I think the only thing in here you need to declare is, integer I, which you can do in the for loop.
Awesome. Thank you so much.
Yeah, you're welcome. Good. Other questions?
Yeah, so when we're uploading everything, so we're uploading the functions, our main function, I'm assuming you want that, is that correct?
Absolutely.
Okay. Do you want like the keywords.txt files and all that as well? Or like any
You do not
test files?
need to put your test file in there, your keywords.txt.
Okay.
But I
Cool.
definitely need all of the .c files. I need index.h, and I need your make file.
Okay. And my next question is like with the make file, I tried to add a comment on this, but it doesn't exactly work like the other ones. Are you okay if like, we don't put like the header comments?
That's correct. Yeah, you only
Okay.
need those in the .c files.
Okay, cool. Thank you.
Yeah.
I had one more for the get word function. I had been
Yeah.
trying to watch the videos over and over, but I still couldn't quite put together where we were supposed to put that null terminator in that function.
In get word?
Yeah.
Okay. So you're passing an argument, which is a character pointer. So it's an array of characters or a string. And your main loop looks like this, right? So first, skip leading spaces. So if there's a bunch of spaces in your input stream right now, skip over those. And then read a character if part of a word. Append to, this output string word. And go back up here and do the other things. If it's an end of file, you want to return end of file, right? If it's a letter, right? So, or an alpha, you append it to the word. And so you do that like we did in the ODPs. You have an output array and you have an output location, and you just keep copying each character to the next output location. And then when you're done making the word, you want to add a null terminator. Well, the easiest way to build this word as we're going is to have some output location initialized to 0. And to append to a word, you can say word bracket output location ++ equals whatever character you read. So the first character that you read that's part of your word gets stored in word bracket 0. Output location becomes 1. The next character you read would be stored in word bracket 1, and output location becomes 2. So when you're done with all of this, when you finally read a space or an end of file, output location tells you where the null terminator goes. And so if you've done this the right way, it looks just like your ODPs, right? You just throw a null terminator at that next location. So if you read the word ABC, you would have stored ABC at indices 0, 1, and 2, and now you put a null terminator at index 3.
Okay, so like right after the is alpha function, if that makes sense.
After the loop, so this is some kind of loop that's reading characters, and if the character is an alpha, we append it to the word. When you read a character and it's not an alpha, it's either end of file or it's a space.
Got it.
So
So
then you
outside
want to
of
go
that
ahead and
while loop.
terminate the word.
So right outside that loop.
Yeah.
Got it. Awesome. Thank you.
Mm-hmm. And it should feel pretty similar to these ODPs of recent times. So like the remove one function, for removing the first X, well, let me go back to rem. Or maybe mix. So the mix function, which was ODP 414, we were combining two strings together. So we were building an output string, right, which was an argument. And we started with an output location of 0. And each time we copied something to that string, we incremented output location. And the comment I put on Outlook was, this tells us where the next character is going to get stored in this output array. So when we're done adding the stuff that we actually want in the output variable, Outlook is still telling us if we had one more thing to put into the string, this is where it would go, Outlook. And we do have one more thing to put onto the string, that's the null terminator. And so we'll say out bracket Outlook equals null terminator.
Got
And
it. Thank you.
the really only correct way to do a null terminator is like that. That says ASCII code, the character with ASCII code 0, that's what the backslash means. EOF is actually a symbol that equates to -1. And so if I set this last character equal to EOF, it's not a null terminator. And my string will continue until it finds an ASCII code 0. So use this instead of EOF. All right, other PA2 questions? We'll go back to the ODPs after this, but other PA2 questions or other questions?
Could you quick run us through how to actually, I don't know why, but I couldn't figure this out from the manual we got, how to actually test our function like against a input from Studio N or stdin?
Which function?
Just like the whole program itself.
So the whole program, if I go into /temp/PA2, that's where the sample code was, right? So I could just say index, and this is a test. Hello, NASA is cool, bye. And then when I'm done typing in at the beginning of a new line, I'll just hit Control D, and it'll go ahead and do my tally. And in this case, my keyword file had all of these words, and it found the word NASA once and no other keywords. But if you have a larger test file like this, right, you could type all of this in, but you can also say redirect standard in from a file. And now instead of having to type input, it will read from this file as if I had typed that input. And when it hits the end of this file, it will do the same thing as if I had typed Control D at the keyboard. It'll say you've hit the end of the file, and then it shows me my tally.
And that will actually test it against our program.
So if you want to test against your program, I think I put some sample in here. So you can make your own keywords .txt file and input file, and then from whatever directory you're in, say /temp/index less than your input file, that'll read your keywords.txt in your current directory and test the sample program against your input file and your keywords file. And then if you want to test your program, just say index less than my input file. That'll run your index program, and it should give the same results.
That's what I was a little confused about. How do we go about making our own input file? Because I had asked the Discord, because we were supposed to get input from Studio In or whatever it's called, and they didn't quite understand what I was saying when I wanted to make my own input file.
So your program normally, when you say fgets or you say getcar, it reads from what we call standard in, stdin, right? And if I say index, and there's, getcar is inside here, well, all the stuff that I'm typing, that's what it's reading, right? That's what's going into standard in. But so let's see up here. So here was my test before. So if I say index and I type in, this stuff at my keyboard and hit Control D, that's the result. If I want to make a test file, I can make a test file and put all of this stuff inside it and then say index less than test file. And it's exactly the same thing as just typing this stuff at the keyboard. So your program is always reading from standard in. What you can do is you can change what standard in means, right? Normally it means read from the keyboard. But if I run a program and I say less than some file, then standard in means read from this file. And you can put whatever you want in this file, and it's just a plain text file. So I can, put whatever text I want in there. And then if I say index less than and the name of that file, it reads standard in from that file.
Awesome.
But
Perfect.
there's nothing special to making that file, right? It's just plain text.
Perfect. That's what I was looking for.
Okay, cool.
I had a question about fgets and I believe the read keywords function.
Okay.
I'm a little confused how it's supposed to grab just one word at a time if fgets reads until a new line, if that makes sense.
Yeah. The quick answer is don't use fgets to read standard in. So when you're reading keywords, fgets works great because the keywords file, I've said there's one word per line. So fgets reads an entire line. And since our keyword file has one word per line, this works great inside there. But in your get word function, where you're trying to read and build up a single word, you're much better off using something like getcar, which reads just one character. And to make life a little easier, what you actually want to use is my getcar, which uses getcar to read a character, but then converts to uppercase and so on and so forth. But get word is reading one character at a time. And it reads a character, and if it's an interesting character, it adds it to the end of the word and reads another character. And when it gets to a space, then it stops reading and it just returns what it's read so far.
Okay, so the keyword file, it's just like word, new line, word, new line,
Exactly.
basically. Okay,
Mhm.
so I need to alter my test file then. Okay, thank you.
Yeah, yeah. Yeah, and keywords should be like exactly what you just said. It's just word new line, word new line, word new line. And there could be uppercase, lowercase in here, but you're not going to see any punctuation, anything that's not a letter, any spaces, things like that. So fgets works well there.
Okay, cool. Thank you.
You're welcome. Other questions?
So, I was working on my tally function, and I was writing a test for it, and I keep getting this error that I passed an invalid argument to it, and it says expected car star, but the argument is car star 32. Isn't that also a car star, or do I need to change do I need to have like my index.h to define tally to this second argument to take a star and then 32 instead of a star?
So everywhere that you talk about the keyword array, which is the second argument to read keywords, the second argument to tally, and the first argument to display results, declare it as car variable name bracket 100 bracket 32. And don't use any stars in there.
Oh, including in the index file?
Including in the index file. The index file should basically just, include these lines pretty much verbatim because they're just function prototypes.
Okay, I thought they were just supposed to be the types and not the not have the names for them.
Yeah, so there might be a way to make it a 100 by 32 without a name, but I don't know exactly if you can just say car bracket 100 bracket 32. I don't know if that would work or not. But you can always put a word in there. Let me try this though. I'm kind of curious. I'm just doing a quick test on that. I think that works. I think if you say car bracket 100 bracket 32, I think that still works. But it looks kind of weird, so it's kind of nice to have the variable name in there anyway.
Yeah, I didn't think that you could have variable name, but apparently you can.
Yeah, prototyping is funny that way. It does not require the variable name, and it doesn't do anything with it, but it lets you put it in, and it's kind of useful because you can look inside and see more quickly. So what do these arguments actually do? Especially when you've got 3 or 4 arguments, it's an easy way to look and say, oh yeah, keywords and then tally and then number of words. But it pretty much ignores the variable name itself. But most often when people are writing C code like this and they're making, a prototype, easiest way to do it is just go into your function declaration itself, copy that, line in the beginning of the function and just add a semicolon to the end. And that changes it from the start of an actual function to a prototype. How do we pass a word to the main function from get word? So get word, So here's your main program. If I have something like car word bracket 100, if I say get word, then inside this function, anything I do to that argument actually affects this variable. So we don't really have to explicitly, pass it back somehow, because since this is an array, if get word, changes word bracket 0 inside its code, this word bracket 0 will change accordingly. It's actually the same locations in memory. And that's peculiar to arrays or pointers more generally. If I pass an integer and I change the value of that integer, it doesn't, change the integer in my main program. But for arrays, it does. Yeah, you're welcome. And remember, at the end of get word, if everything succeeds, you also want to return word. We don't actually do anything with that, but it's in contrast to if we run out of words, we return null. And that's how our calling program knows we hit the end of the file. So if we return word that's not null, it'll tell main in this case, hey, there's more stuff to read. So go ahead and read another word when you're ready. All right, cool. What else?
There's no chance you want to run through like the bare bones of a make file, because I think that I did it right, but I'm not 100% sure.
Yeah. So let's see. So I mean, if you've got stuff pushed over to Git, or you've got some other backup system, right? You can just try the make file and sort of tell if it's doing the right thing or not. But let's hop into some sample code. So this was our sample code we were playing with for make files. And the way I know that this is doing the right thing is if I say make clean, it should get rid of everything except the source code files, the .c files, the .h file, and the make file. And if I've gotten rid of all that other stuff and I say make, it should build an executable program, but it should do it in pieces. It should compile each of my C files into an object, and then take those 3 object files in this case and combine them into an executable program. And if I say make and I just get one GCC that just compiles, everything .c into an executable, then it's not what we call a good make file, right? It's not being very picky about what gets compiled. But this is, clearly compiling each function separately and then linking them together. And if I say make again, it should say everything's up to date. And then if I say touch, fun.c, for example, which makes it look like fun.c has been edited, and I say make, it should recompile just fun.c, which creates a new fun.o, so then it relinks these .o files into main. And then if I say make, everything's up to date.
So I tried to
And if I-
essentially copy this for my functions, but I kept getting a not a clean target error, something like that.
So the only real difference other than, different function names for PA2 is your main program is probably going to be called index.
Yeah,
And I
called
would
it that.
suggest, using an index.c instead of a main.c, index.h, index.c, index.o, index.o, index. And if it's talking about a target not being found or no recipe for a target, it may be that you've got a main kicking around instead of an index or vice versa. But the way to read this is if I say make, this is the thing it wants to build. Whatever that first line says is my target. And if I'm going to use a main.o, I need to have a line that says, how do I make main.o? If I say index.o, I'd need to have a line that says, here's how you make index.o, and so on.
Okay, yeah. So if it says something like recipe for target index.o failed, that means
It means you probably said up here you needed index.o, but there's no line that begins with index.o in the rest of the file.
got
And
it.
so it doesn't know how to build that file.
Awesome. Thank you.
Okay, you're welcome. Let's see, why are we writing an input statement into standard in? And it doesn't list the keywords and tally them. Doesn't mean there's something wrong with my display results. No, so let's go back into temp PA2 and let's run the index program. And as I type, it's not going to do anything, right? And that's normal because it's counting, right? And it can't display the results until it's seen all of the input. So if you're running your test program like this and you're typing, from the keyboard into standard in, you should not see any results until you hit Control D. And you have to hit Control D at the beginning of a line. So if I've got, one more keyword here, hit Enter, and then hold down Control and press D, and then it should go ahead and display results. Now, if that's not happening, then probably your get words function is not returning end of file when it gets to the end of the file. And that could be a couple of different things. It could be that that get car is not noticing when, or get word is not noticing when my get car returns EOF, right? Or it could be that my get car is not returning EOF, which means it's not noticing when get car returns EOF. And so we're gonna sketch out some code for testing each of these functions. And I would say start with, my get car and make sure that that's doing what it's supposed to do, including detecting end of file. And if that's working, then you can test get word and make sure that's detecting end of file. And if you're not getting any output, I'd say probably one of those is not responding to or returning end of file the way it needs to. Or possibly your main program is getting end of file from get word, but not doing anything with it and just keeps trying to get words. And a test program for get word will show you how to handle the end of file there. Welcome.
Yeah, I have kind of a silly question.
Mm-hmm.
So I just kind of had a forget moment. So the .h file, like main.h, is just passing the header files into all of the other functions, correct?
Yeah, so the .h file is really just the prototyping. So it's just the function prototypes. So whatever functions I'm going to call from other programs, I need to tell the compiler, hey, what type of arguments does it take? What type of value does it return? So I put that inside main.h. And then in main.c, I can just say include main.h. And if I don't do that, and I say make, I get these warnings about, hey, you're using a function named fun, but you haven't told me what kind of function it is, what kind of arguments it takes, what kind of value it returns. And so it's saying it's just making some assumptions, which I think is it's going to assume it takes an int and returns an int. So the way we get rid of that is we put these function prototypes in. And we could do this by just, you know, typing in the function prototypes in the beginning of main. And that would work fine. But it's cleaner to have this include file that contains those two lines that make up the prototype. And so we can do that. And then if I have, you know, a new function that I write that I need to include, instead of putting it in a bunch of different files that might call it, I can just put it in my main.h. But include main.c is basically, main.h is basically saying, take the contents of this file and put it right here. So it does this, right? It effectively just adds those lines into my file here. But it does it without me having to type them explicitly. So it just pulls them in from this file instead.
Okay, cool. Thank you.
Yeah, you're welcome. All right, how can we store the keywords array in memory for use in other functions? So if in our main program, so this is inside main, we say something like character, keywords, bracket 100, bracket 32. So that sets up storage for an array of strings. And when we call something like read keywords, and we pass this, so, you know, the file name, and we pass the second argument as this array, the code inside here basically sees this argument and it starts copying strings from get word right into the elements of this array. And so if somewhere inside read keywords, I said something like, you know, string copy, keywords, bracket 0, comma, word, right? That would take the characters that make up this string and copy them into the first element of this array. And in my main program, that changes what's stored in this array, right? It actually updates this array because I passed that to my read keywords function. And when I pass this same array to my tally function, for example, it'll be accessing, you know, the same strings that are actually in this array. So I don't know if that answers your question or not. Cool. All right, let's take a quick look at the last ODP. Which was this remove one function. So this is supposed to remove the first letter X and then copy all the other characters directly. And yeah, we're going to go over test functions next. So this looks like the remove function. Right, so this was ODP 416. And it basically, you know, iterates over each of the characters in the input string. And if the character is not an X, it copies it to the output string and it increments the output location. And I did a small trick here. Instead of going up to string length -1, I said less than or equal to string length, which will include the null terminator. So that takes care of terminating the string at the end. But this is the main action, right? If the input character is not an X, copy it to the output. So 417, which only removes the first X, does almost exactly the same thing. Here's the similar line. If the input location is not X, copy it to the output location, but it's got one extra tweak in it, which is this flag. So I have this flag called done. And the way I'm thinking of done is done says, have I already removed an X? And so I initialize done to 0, which says, no, I have not already removed an X. And the first time I find an X, we set done equal to 1. So now this main action statement in the loop says, hey, if you've already removed an X, or the current character is not an X, copy it to the output. So what happens the first time that you encounter an X? Done is a 0, right? We have not already removed an X, so done is 0, that's false. Input character iloc is not equal to X, that's also false because the input character is an X. So this is false or false. This whole statement is false. We don't copy that X into the output. But since that character is an X, we set done equal to 1. And this statement is setting our flag. It's saying, hey, from this point forward, you should remember you removed an X already. And for the rest of this loop, this if statement is going to say if done, well, done's equal to 1, so this is true. And so it's always going to copy the next input character to the next output location. And so that's this idea of state, right? This is adding state information to the program so that as the program executes, it knows, have I already done this thing I'm supposed to do, remove the first X? And this statement now does two different things. If we've never seen an X and we got an X right now, it will skip it. If we have seen an X or this character is not an X, it will copy it to the output location. And so that's what we mean by a sense of state, right? It means that the behavior depends on what's happened in the past. And it's in the spirit of a state machine from Engineering 250. In hardware, we use flip-flops to record how the system has changed over time. In this case, we're just using a variable. And we use that to record when the system moves from one condition or state to another. So everyone okay with ODP 417?
Yeah.
Cool, lots of thumbs ups too, that's good. All right, well, let's start talking about testing functions for PA2. And let's start with the lowest level function, which would be my get car. And so this is like get car, right? It should basically read a character and return it. But unlike get car, it does some extra processing. So let's write some work code. All right, so let's write let's build this up step by step. So let's do.
Question.
Yeah.
Why did you put index.h in quotation marks when you were typing it?
Because that file is in my current directory.
So the angle brackets are for like universal kind of standard files.
Exactly.
They all have
So
those.
if I say something like this, include angle bracket index.h.
That's going to throw an error. Good to know.
That's going to throw an error. And the error is no such file or directory. So the angle brackets say, let's look in the directory /usr/include. And if you look in there, you can find standardIO.h right there. You can find math.h. You can find ctype.h, right? All these things that we normally include. But index.h, nowhere to be found in here. So if we use quotation marks, that says look in the current directory.
Well,
And then that
that's good
should
to know.
compile fine. All right, so let's just do let's do a simpler test. So I'm going to call get car, and I'm going to print out that character twice, once as an integer and once as a character. So a %d and a %c. And I don't need this right now. So this is just a basic get car test. And if I run this and I type the letter A, it tells me C is 65, which is character A. And if I run this and I just hit enter, it says C is 10, which is character, and there's a new line, hopping down from one line to the next. And if I hit a control D, it says C is -1, which is character, looks like half a question mark and a diamond. And -1 is the same as EOF. So get car is getting us one character. So if I want to test my get car, I can call my get car. And now if I try to compile it, I'm going to get a bunch of issues. The first is this implicit declaration. Now get car, that's defined in standardIO.h. But my get car is not defined anywhere. And so there's this warning saying, hey, you're calling a function. I don't know what that function should be. So I need to prototype it. And so this is where I'm going to say include index.h. And in that include file, I say, hey, here's what my get car looks like. It takes no arguments. It returns an integer. So by including that, I've got my function prototype and any other prototypes that I have. Okay, so now if I try to compile this, it will compile, but I still get this error saying undefined reference to my get car. So what I would normally do is I would say my get car.c. Well, I can do that. So I can do my get car.c. And now if I say test my get car, I can type an A and there's an A. I can type an enter, and it changed my enter to a space, which is good. I can type a control D and that gives me end of line, end of file, and that's good. But we'd like to do more extensive testing on this. So let's just put this thing in a loop. So now we'll keep calling get car. So I can say this is a test, and you can see that it's converting my lowercase letters to uppercase. It's got spaces in between words, which is fine. And my new line at the end got changed into a space also. So I'm hitting tabs here, and those tabs should be turned into spaces also, and they are. So character 32 is a space, and it looks like just a tab. And if I type things that aren't letters, like HE with a bunch of stuff and then an O, all I get back is HELLO, followed by the space, which came from the new line. Right, so the goal of my get car is to deal with those special characters and ignore them, convert lowercase to uppercase, and convert all forms of space to a single space. So this is much easier input to process than this. So if this is what my get word is seeing, right, it doesn't have to worry about uppercase and ignoring punctuation and things like that. So this is a pretty solid test of my get car. And I'm just making sure that, you know, these things are being ignored, these are being ignored, and so on. Lowercase letters go to uppercase. And then the last question is, what happens when I hit the end of the file? And so if I hit a Control D, now I just get a bunch of -1s. And I'm getting -1s because I put this all inside an infinite loop. And so I could do, you know, something like if C equals end of file, let's just return. And now if I hit a Control D, it shows me my character was -1 and my code said, hey, if you got a -1, which is end of file, let's return. So if you're getting that kind of behavior, I would say my get car, that's in the books. Totally done. All right, so let's try get word. So get word, remember, is reading an entire word. And so instead of an integer, we've got an array of characters. It only has to be 32 bytes, but I'm just making it 100 so I don't have to worry that I'm going to run out of space. And I'm going to say get word. And let's just print out our word. So if I compile this, right, it compiles fine, but it's missing the function get word. So I also need to compile get word.c. And that compiles, but get word.c needs my get car. So I also need my get car.c. So now I can build my function and I can say test get word. And I can say something like this is a test. And I got 4 words coming back. This is a test. I can say, you know, a bunch of spaces and then hello with some stuff in the middle and maybe some tabs and, you know, add some other punctuations. And what I get back from get word is super duper clean, right? I've got all this gibberish in my input line, but get word just saw hello, how are you? 4 words. So all these tabs and all of these spaces in the beginning does not trip it up. The digits, the weird punctuation does not trip it up. The lowercase gets converted to uppercase. And this is what you want get word to do, right? Take your input and chop it up into these nice words. And so if I take all of this and I feed that to standard in, right? My words are nice and clean, right? They're just collections of uppercase letters, no punctuation, so on and so forth. All right, so here again, if I hit Control D, that'll signify the end of input. And since I'm in an infinite loop, I just get this infinite output where it just keeps saying word equals. So we want to detect that we've reached end of file. So we can do that with an if statement. So get word is going to return a pointer. And so we can say if get word returns null, let's just return, we'll just exit our function. So now in the beginning of the line, I'm going to hold down Control, press D, and it just exits cleanly. So it detected the end of the file. So pretty simple function for testing get word. And get word also tests my get car. So if you have faith that my get car works, you could just use this, test get word, and if everything looks good, you're probably in good shape. Right? Or you could use that previous function to test my get car. But in either case, not a whole lot of very sophisticated stuff going on here. It's just calling the function, printing the return value. Here it's just calling the function with an argument, printing out that argument. All right, so let's take a break. Let's take a 5-minute break or so, and then we'll continue and we'll do the other functions. I'm gonna have to end class about 5 minutes early today. So I'm gonna have to leave at 12 instead of 12:05. But we should have plenty of time to get through all of this. So let's come back in 5 minutes. Yeah. All right, welcome back. I take it people can see my document camera and stuff like that, right?
Yeah.
Okay. Zoom used to put a green border around what it was sharing, and it doesn't seem to be doing that. Maybe because I'm recording. Hold on, let me pause the recording. All right. Well, that's a nice feature, I guess. All right. So let's continue with these functions. So we've got myGetCar and getWord. And we're kind of working from the bottom up here, right? With those two functions. Let's look at read keywords. So read keywords opens up the keywords file, pulls in the keywords, saves them in memory, returns the number of words that it read. So we don't need a loop here, but we do need an array that's 100 by 32. And we're going to store our keywords in here. And it needs a number of words variable that we're going to store the result from read keywords in. So we can say read keywords. And I can read from a file like test.txt and load it into the keyword array. And then let's see how many words it reads. Minor typos. All right, so let's try that. So I can compile this, it compiles fine, but I need to have the actual function itself, which in this case is in the read keywords.c file. So compile that, it runs fine. We can run test read keywords, and it comes back and says number of words equals -1. And that's exactly what it should do because I'm reading from a file called test.txt, but I don't have a test.txt. So let's make a test file. So I'll put 5 keywords in my file. And now if I run test read keywords, it comes back and it says, hey, I read 5 words. So that's progress. And this is a point where jumping into GDB might be useful. Now I could go ahead and I could make a loop and iterate over the number of words and print out the elements in this keyword array. But let's do this in GDB just to get some practice with that, and because it may make things a little easier. So I'm just going to put a -G switch right in the beginning of my GCC. And I'm going to say GDB test read keywords. And so it told me it read symbols, didn't give me any bad messages. And so I can say start. And I can say N for next. So it's about to call read keywords. I'm going to hit enter, which will execute the next statement and come back after it returns. And so now I can say print num words. And I see num words is 5. But this array KW should be populated with 5 keywords. So if I just print KW, and P is short for print, I get the following. It tells me inside curly brackets, right? The first element in my array is HELLO, followed by a null terminator, null, null, character 220, 341, etc. Null terminator, 17 more nulls. Now, if I count this up, HELLO is 5 characters. 6, 7, 8, 9, 10, 11, 12, 13, 14 characters up to here. another null terminator that's 15 characters, and then 17 more null terminators, 15 and 17. That's 32 bytes. So the first element in my array is 32 characters, starting with HELLO null terminator. That's my keyword right there. And then the other 26 bytes are just whatever happened to be in memory. All right. And then it starts a new line and it says the next word is cool, COOL, followed by a null terminator. So that's 5 characters, and then 27 more null terminators. That's the 32 bytes making up my second keyword. And the actual keyword is just cool, followed by a null terminator. Third is fun, fourth is weird, fifth is by. And then the sixth keyword is this, which doesn't look meaningful, but we didn't load a sixth keyword, we only loaded 5. So the sixth element in this array is basically gibberish. So is the 7th and the 8th, and so on. And I can go through my entire file, my entire list of keywords, and they're all pretty much meaningless except the first 5. But while I'm in here, I can also play around with syntax. So if I say print keyword bracket 0, I can see, oh, that's, a string. It's 32 characters starting with HELLO null terminator. If I print keyword bracket 2, that's another string. It starts with fun followed by a null terminator. So these things, the name of my array, bracket some index, those are strings. And those are what we want to be able to store in here, right? This is an array of 100 strings. And that's where we're going to pass the tally and display results and so on and so forth. So from looking in GDB, it looks like this is working well. And if it wasn't, right, I could say start, and I could say step. But then instead of saying next here, I could say step, which would go into the read keywords function. And now I could start doing next to actually run through this function itself one line at a time. And so I can see it's doing an fgets data bracket num words. And, I can print out num words and see that it's 0. And I can print data bracket 0 and see that that's my hello followed by a new line and so on and so forth. All right, so GDB can work for some or all of this, but let's say we also wanted to do this without GDB, or we wanted to, see a more thorough test, something more convincing. We could just iterate, right? So num words is the number of keywords that we have. And so I could do something like for I equals 0, I less than num words, I plus plus. So I'm going to print out KW bracket, my index, equals, and then as a %s, I'll print out the actual keyword. So I'll say how many words I got back from the read keywords function, and then I'll loop and print out each of the keywords. And if I do that, now I can see really clearly, hey, I read 5 words from my keyword file. Hello, cool, fun, weird, bye. And they had lowercase in them, but it converted them to uppercase. So that's good. So that's a pretty thorough test of read keywords. And the 2 main cases you're checking are, one, if the file doesn't exist, it should give you back -1 is the number of keywords. If the file exists, it should give you back the number of words that it read. And remember, the keyword file looks like this. It's only 1 word per line, no spaces anywhere, just a new line at the end of each. and no punctuation or weird characters in here, just letters, uppercase, lowercase. All right, so display result. Yeah, let's do that one last. Let's let's do it now. So in VI, you can say :W followed by a file name, and it will write the current file into that other file name. It doesn't change the name of this file. This is still test read keywords. But I just created this test read test display results file over here. And after you write a file, you can get to it from inside VI by saying :N for next, and that'll by hitting Control-6. And this is a weird but really useful VI shortcut. Control-6 moves you from your current file to a second file. And so if I :VI another file from inside VI, Control-6 gets me back and forth between the two files. If I :W to write a file, then Control-6 took me into that new file, which is test display result. That's just a shortcut. So let's display our results. And suppose we don't have read keywords working, right? We don't need that in order to test our display results. So we could do something like this. Copy keyword (0) hello. And we could just load some test data into here. Right? So what am I doing here? I am manually creating a keyword array. And our keyword array from read keywords is this two-dimensional array. It's up to 100 strings, with each string up to 32 characters. And instead of running read keywords, because maybe I haven't written read keywords yet, I'm just doing a bunch of string copies. I'm declaring my array here. I'm copying hello into that first string. I'm copying this into the second string, and so on and so forth. So this is all just synthetic data that I'm cobbling together by hand. You can always do this when you're testing code. You can make, your own contents of memory to be whatever you want. So if I do this instead of read keywords, oh, and I need to include string.h. Right, then it looks exactly like my previous test. But I didn't get these keywords from read keywords. I got them from just, sort of building this together by hand. So now if I want to test display results, I can say display results. Well, the first argument is the keyword array. The second argument is the count array. And the third argument is the number of words. Well, I need this count array, right? And count normally comes from tally. Each time we call tally, count gets updated. But maybe I haven't written tally yet either. So let's just synthesize our count array. So we're going to do integer count bracket 100. There's a special initialization you can do for integer arrays. I can say equals curly bracket 0. That will set each element to 0. This only works for initializing to 0. Right? This does not work if you want to initialize to -1 or something else. It only works for initializing to 0. It's just a special feature. All right, so that sets all of my counts to 0. But let's pretend we had some interesting counts. So I don't know, 12, 7, 2, 11, and 119. So suppose that's what we got after reading keywords and calling tally a bunch of times. We just want to display results. And it should say hello appeared 12 times, this occurred 7 times, is twice, and so on and so forth. So I can recompile. I have to include display results. And now when I run this, there's my expected results. Hello occurred twice, this 7 times, is twice, A11, and test 119. So display results looks good. All right, good so far. All right, so we got one more function to do, and that's the tally function. And tally does, the actual counting of words to record how many times they occur. But it's a pretty not too bad program to write. Basically, you loop over the array of keywords and compare the word you're trying to tally to each keyword. And if you find a match, just increment the corresponding element in count. So if this was our keyword array and this was our current count array, and we call tally with the word is, right, it would just loop through each keyword. This is not is, this is not is, this is the word is. That's at index 2, it would increment count bracket 2. So let's try this. So I'm going to write my file into testtally.c. And I'm still inside test display results. So I'm going to Control-6. Now I'm editing testtally.c. And instead of doing this, let's do tallies. So we tally a word. So let's try this. We give it the keyword array. We give it the count array. And we give it the number of words. So this would be, normally I'd be calling get word, and it would return this hello, not a word, haha, test. But in my main program's loop, each time I get a word from get word, I'm just going to call tally. I'm going to call it exactly like this, except this is going to be whatever variable contains my word. But I don't have get word written yet, so I'm just testing tally by itself. And if I have display results, I can use that. If not, I can go back and use that for loop that I had. But here I'm saying, hey, I just saw the word this, let's tally that up. And so counts originally all zeros, count bracket 1 should become 1. And then count bracket 0 should become 1. And then the tally for this goes to 2 and 2. These get skipped and test is once. So when this is done, hello should appear twice, this should appear twice, test should appear once, everything else should appear not at all. go ahead and run that. And sure enough, hello and this appeared twice. Test appeared once. These words did not appear anytime. Yeah. All right, so there's 5 required functions, and there's sample code we can use to test them as we're developing. And if things are not working, what do? Well, you've got a couple of options. One option is to throw a bunch of print statements in your code. So if we're trying to read a word and it doesn't feel like, we're reading it successfully, we're getting punctuation or it's looping forever or something, you can throw in a bunch of print statements in your get word code. And one thing you might do, for example, since get word uses my get car, is every time you come back from my get car, put in a nice clear print statement. And if you say C equals my get car, you could put in a debug statement like back from my get car, C equals %D, which is angle bracket %C. New line, comma, C, comma, C. And when you run your program, you're going to get a nice clean message saying, hey, you just called get car. It returned this integer, which is this character. And I see sometimes people writing, debug statements in their code where they just say something like printf C. And so you're just going to get a character appearing in the middle of your output and you have no idea what that is. And people will spend a great deal of time and effort just trying to understand what their program's printing, right? Make things easy on yourself. It takes, 5-10 seconds longer to type this instead of just printf %D, comma, C, but it is so worth it, right? Because if you have several of these statements, right, every time that you find a space in the beginning and you're skipping over it, make a statement, printf, this is a space, still skipping. And when you come out of that loop in the beginning of get word, which is skipping over spaces, print a clear message saying, found something that's not a space, starting to build up the word. And every time you copy a character into the array, print out a message saying, hey, I just copied into output position, whatever output loc is. And the character I copied is such and such. And when you're done with that loop, when you find another space, say, hey, I found the end of the word. I've copied, 6 characters, and now I'm copying a null terminator into position and, print out the value of the variable you're using to place the null terminator. And having all of these debug messages makes it a lot easier to look at what's happening in your code and find where the issue is. Now you can do this in GDB also. And our goal in 222 in winter is going to be to get really good with GDB, because print statements aren't going to work very well for us, because we're going to have variables that don't exist when we compile our program. But for 224, for PA2, especially, when the assignments due this week, print statements work pretty well. It's still a really good go-to. And if you know where the problem is, if you know that, something is getting stored in the wrong place or something like that, maybe if you've isolated the bug, you can use GDB to then actually see your code run one statement at a time and figure out the cause of that behavior. But, prints are always a good way to start debugging, and sometimes that's all you need. The make file you can leave till the end. It's worth points, but you can get everything else working perfectly without a make file. Make sure that you're using Git or something to back up your code. When you start working with make files, you can clobber your code. Right? So if I say something like, GCC-O display results.c, right? That will notice that I'm about to destroy my output file. But if I do anything a little more complex than this, it will wipe out this file. And that's it. My program is gone. And unless I've got a backup of it somewhere, there's no getting it back. You're typing things in from memory at that point. So do your Git stuff, right? If you're doing this under CSE224/PA2, git init, git add star, git commit, and then git push if you want to push it over to GitLab. And then if something goes wrong, if your make file has something that clobbers a file, or if it's just, you've been coding for 16 hours and you delete a file instead of VIing it, you can get back to your code. But usually when students seem to lose work, it tends to be, in the last few days of an assignment, because things are more complex and there's panic and stuff like that. So keep doing good backup habits. If you're not using Git, at least be copying these to something, so that if you wipe stuff out, you can get back to it.
And how do we bring that back down again? Like
if you
from
lose
GitLab?
things and they're on Git,
Yeah, like if say we wipe something out, how do we bring it back down from GitLab?
so whatever directory I'm in, if I say git clone git at gitlab.com:username and the name of the repository, it will create a directory underneath my current directory called CSE224, and all my files will be there. So I would say go into an empty location, right? Make yourself a temporary directory, and then do this clone. So let me just show you. So I'll make a temp work. And then I think I still have a repository under here. So I'm in this temp work directory, which is empty. Go ahead and do this. I deleted my repository. But if you do that, then it should create under here a CSE224 directory. And then you can copy the files from there and put them into your actual CSE224. Or you can log on to GitLab, and from GitLab you can look at your project and see the source code. And there's a download button where you can download it as a zip file if you want, and then unzip it and repopulate your directory from there.
Got it. Thank you.
Yeah. And all it takes is an RM star to get rid of everything. So say I want to get rid of my object files, I could say rm star.o, right? And that gets rid of my objects. If I make a typo and accidentally put a space in there, all my files are gone, right? I just lost all of my PA2 work. Because what I said was remove all the files and then try to remove a file named .o. Well, it didn't find a .o, but it found lots of stuff to remove that matched that star, namely all of this stuff. And that's it, file's gone. So it's really easy to lose stuff. So backups are your friend. All right, other questions? All right, well, let's talk bash a little more. So we started talking about bash and scripting, and we looked at how we can do output by saying echo. And so we could say echo hello, and it says hello. And if we put things inside double quotes, it looks exactly the same. But if I say echo asterisk, if I say echo asterisk, it doesn't display an asterisk. It displays all the files in my current directory that match anything. And if I really wanted to display an asterisk, I could put it inside double quotes, and that'll just display that character exactly. So usually we put things in double quotes. Double quotes also take things that might have spaces in them and sort of gloms them together to be a single thing. And that's useful sometimes. So that's the first kind of quotes we can use. And generally we'll put things in double quotation marks if there's not a clear reason not to. So then we talked about doing input. And if I say, you know, read name, and I type something, then this variable has been given this value. Now, if I echo name, it just says name, but if I want to echo the value of this variable, I put a $sign in front, and it says, oh, that's the value of that name. Now, if I want to assign a value using an equal sign, I can say name equals John, and if I echo name, it's John. If I say name equals John Smith, I'm going to get errors. But if I put this inside quotation marks, I'm saying name equals, and it's just one thing. It's all of this. And now if I echo $sign name, it's John Smith. So double quotes are nice for grouping things together that might contain spaces. Bash is very sensitive about spaces. And it's sensitive enough that even if I do something like this, name space equals, it'll freak out. All right, so I could also echo, you know, double quote $sign name. And I could say something like this, your name is $sign name. And it substitutes John Smith for the name. And if I do this without quotation marks, that seems to work fine. Now, if I say your name equals John Smith, that works fine. But if I do that without quotation marks, oh, that still works too. Okay, I was going to make that fail, but it worked. So that's okay. But what if I wanted to say this cost $100? It says this costs 00. And the reason is that a $sign says, hey, I want to interpret the value of a variable. If I said the value of $sign name is $sign name, it says the value of John Smith is John Smith. So we can use single quotes, and a single quote will stop the $sign from being treated specially. So if I just say single quote, the cost is $100, it says the cost is $100. And now if I do single quotes around here, it'll say the value of $sign name is $sign name. Let's see, how do we add all files under PA2 to GitLab? Git So you have to be in the PA2 directory. You can say git add asterisk, and that'll add all the files, .c, .h, .o, make file, any test files you have, everything gets added. And then git commit. And then to push it to GitLab, git push origin master. So the star matches everything. Welcome. All right, so there's a third kind of quotation mark, which is this back quote. So on my keyboard, it's up there under the tilde. So the forward quotes are single quote, double quote, and then the back quotes up here. And back quotes have a special meaning in Bash, and it's a wonderful meaning. So if I say X equals double quote date, and I echo $X, it's just equal to date. If I say X equals single quote date, and I echo X, it's again just date. But if I say X equals back quote date, and I echo X, it's actually equal to the date. And that's pretty exciting. And if I echo it again 20 seconds later, it's the exact same date that I got up here, right? X is just a variable. It's not a magic command that tells me what the date is. It's just a variable. And it happens to be equal to this collection of characters. And unless I change it by setting X equal to something else, that's all that X is ever going to be. But where did these characters come from? Well, they came from up here when I said X equals back quote date. And so here's the thing that Bash does with back quotes. If I say, you know, some expression in Bash, and I include a back quote pair with a command inside, it executes this command. It captures whatever is sent to standard out, and it replaces this with the output of that command. So if I say X equals back quote date, it runs the date command, it captures what it sends to standard out, and then it replaces this with that string. So Tuesday, et cetera, et cetera. And so the command it actually executes is X equals Tuesday, 18th October, 2022, 11:33, et cetera, et cetera. So if I say X equals back quote print working directory, and I echo $X, it's the result of the PWD command. And again, if I go to a different directory, you know, PWD gives me something different, but X is just a variable. If I echo $X, it's you know, what whatever that variable was equal to. So I can do something like this. Echo quote, your current dir is back quote PWD. And it says your current dir is /home/Nick. If I change directories and I run that same command, it says your current dir is /home/Nick/files. So this is a really powerful thing. It's executing a command, grabbing standard out from that command, and then substituting this expression with the standard out that it captured.
So quick question.
Mm-hmm.
It seems like all variables in Bash are just base strings.
Correct.
Okay.
And so if I set X equal to 2, and I echo $X plus $X, I just get 2 plus sign 2. So if we want to actually do arithmetic, we do $paren and put our expression we want to evaluate inside the double parens, And that'll give us our 4. But unless we do something like this, $paren, everything is just a string. And so we don't have to declare bash variables. They're usually just strings. And we can do arrays and things like that, but we're not talking about those yet. We'll get to them later. And let me see. So if I say x equals ls/bin, and I look at $x, it's a big, long, space-separated string. And each thing in here is one of the files that was printed by ls/bin. So if I do ls/bin, right, there's a list of files. Well, when I set x equal to that, it just turns it into one big, long string with a bunch of spaces. And if I did x equals ls-l, and I echo $x, well, now I got a big mess, right? Because ls-l prints out, the permission bits and the file ownership and group ownership and the size and the date and the name of the file. And all of that gets sent to standard out. So all of that basically replaced this. And it's exactly the same as if I said x equals, quote, all of this stuff. So now I've got a big, long variable. So one reason this is useful is because we can execute commands from a script, right? We started talking about scripting. We can execute a command from a script and capture what that script generates and then do things with it. So maybe I want to send a message to every user who's logged into the system. So I could say who, and it will show me the people who are logged in. If I say x equals who, I have a variable that contains, the usernames of each person logged in. Well, it's got some other stuff in there, but I could say, who, and I could use my pipe to take this output and send it to the input of another command. So we're going to learn a command called awk. And if I say print $1, that prints the first column of each line of input. So this prints out just, the usernames of people who are on the system. And I can pipe that into a command called unique to get rid of duplicates. And now if I say x equals all of that stuff, and I echo $x, hey, that's the only user who's on the system. And now I could say, let's write to that user. And I could send a message, except I don't have write permission turned on. But I could send a message to Nick, that's myself, and say, hello.
So where can we put these scripts so that we can use them, the scripts that we make?
So if you have a script in your current directory and you type the name of it, it will search in your current directory. So, so for example, so inside here, I have a script called do countdown. And if I say do countdown 11:55, it throws a message up here that counts down until 11:55. So that's what I use, like, in between breaks and stuff. That's a script in my current directory. So just typing that, it finds it. If I don't happen to be in that directory, it doesn't know what that's called. But I could say tilde/file/useful command/teaching/do countdown, and I can put in the full path to it, and that'll execute it. But the other thing you could do is you could create your own version of a bin directory. So if I look at $path and $path, right, that's just showing the value of this variable called path. Well, path is a special variable that's always available in bash, and it basically lists the directories that will be searched for commands. So I have a file under my /home/nic/.local/bin. I have a directory with this name, and any command that I type that isn't found in any of these directories, it will, as a last resort, check this directory. And so if I put a script in this directory and I type the name of that script from anywhere on my system, it'll find it in here and execute it. And this is exactly the same way that system commands work. When I type ls, it starts looking in these directories for ls, and eventually it gets to /bin, and it finds a /bin/ls, and it executes that file or script. That's a file, but if it was a script, it would do the same thing. So you can make yourself a /home/your username/bin and put your scripts in there, add that to the end of your path. And then anytime that you type the name of a script in that directory, it'll find it and run it.
How do you add it to the end of your path? Just like, yeah,
That can be a little tricky. So I do it like this, right? I set path equal to double quote $path : and then I added something else at the end of that. And so that takes this and it replaces it with the current path, and then it adds an extra colon, and then it adds this piece to the end of it. It can be a little tricky because if this gets messed up, then you can't execute any commands until you log out and log back in again. And if you do this in your bash RC and it messes up your path, it'll mess up your path every time you log in. And so you've got to be a little clever to get out of that. Instead of saying VI, you can say /bin/VI or wherever VI happens to be. But something like this, or you can just kind of hardwire the path to be, a set of files. But it's better to just append something to it. So here I just added one extra directory to the end of my path. And I did export to say that if I start a new shell, I want to go ahead, and you don't really need the export, I don't think. But I did an export to say, hey, if I start a new shell, send this new value of the path to that shell also.
okay, that makes sense.
The other thing you can do is you can set up an alias. So wherever I happen to be, I can run this cam setup command, which is another script. And that's just an alias to Nick files useful commands teaching cam setup, which is a script. But I can set up this alias inside the bash RC file. So this gets executed every time I log in, this alias appears. And now if I say cam setup, it's a shortcut for this big long line that I don't want to type every time. And to set that up, I just say alias cam setup equals, and you can see some of the scripts I have shortcuts to for teaching. So countdown, prepare uploads, process grades, question GUI, and so on and so forth. And then each of these things is just, a bash script. Starts with bin bash. You assign values to variables, you execute bash commands, you do if statements. There might be some looping and so on and so forth. But instead of doing all of this stuff every time that I want to set up my cameras, now I just say cam setup, and it takes care of all of this for me. I can go to a window, I can hit Control-Alt-S, and it'll be sticky, so it shows up on all of my desktops. But I can also do that with this wmctrl command. And I can say make it sticky and make it show up above all the other windows. So these are just ways to minimize how much point and click I have to do. All right. Hopefully some of that's helpful. I have a 12 o'clock appointment I need to get to, so I'm going to let you out 6 minutes early. And keep pushing forward on PA2. Come by office hours if you run into questions. Stay safe with the crazy events going on. And I will see everybody next time. You're
Bye.
welcome. Have a good one.
Have a good one.
Thanks.